Hi everyone, I'm sorry for the trouble we were having earlier. So here is a solution for the example we were looking at. We were trying to look at some quadratic formula, quadratic function word problems. So here you have one example 2 from what I posted in the review. Just up on the announcements is where I posted that. Now let's have a look at this. So we have a ball is thrown vertically upward from the balcony of an apartment building, then falls to the ground. The height of the ball, h, in meters after t seconds is given by the formula. H equals negative 4t squared plus 24t plus 6. And as I was saying, I always rewrite my equation just to get it out of the context of the word problem, isolate it a bit. It lets me examine it a little better. So right now, even, and also for me at least, as I write it, it lets me focus on the different elements of it. So here I know that I have a negative a value, means my parabola opens downward, means I have a maximum value. Obviously for this one we were given the context of the question quite clearly, so that's helpful, but sometimes if you're not, it's important to look at those things. So for part A, and this is a very typical question, it says determine the maximum height of the ball. When you are asked, and you need to be looking for these key things, when you are asked to find the maximum or find the minimum, if this is me, and here's my thought bubble happening here. Sorry, I don't want to mess that up completely. When I am asked to find the maximum or minimum, immediately I think vertex form. Because the vertex, of course, is the maximum at the time that it occurs, right? So immediately I think I want to put this into vertex form. So next thing in my thought bubble is, what form do I have now? Well, right now I have standard form. And you're reviewing everything here. How do we go from standard to vertex? We complete the square. Okay, sorry, to get to vertex. This is how we do it. We complete the square. All right, so I'm just gonna, if it will let me, I'm just going to get rid of a little bit of this, a little bit more space, and let's not. Okay, never mind. We're just going to continue. We've been struggling this morning. Anyways, so now how do we complete the square? Well, we always have to factor out a. If you want, we did some examples previously where we're bringing to the other side of the equation. We're going to go straight from here. So I'm going to factor out the a value. I'm factoring out the negative, remember? So I'm left only from my first two terms. And I'm in standard form, so my first two terms should be my variable terms. So I'm left here with then t squared. I factored out negative, so I'm going to be left inside with a negative, and of course 24 divided by 4 is 6, so I'm left with negative 6t, close my bracket, and I did nothing to my c term, so it's still there. Next, I'm going to actually create the perfect square within my binomial here, so still negative 4 out front. How do we determine the number that we are going to both add and subtract? Well, we take our coefficient for b and we divide it by 2. So we take 6 and divide it by 2. That equals 3. And then remember, we square it. Okay, so 3 squared, of course, equals 9. So I'm going to add 9 and subtract 9. I need to close my bracket and plus 6. Next line, negative 4 stays out in front. And I'm now going to express my perfect square trinomial as a binomial squared. So I have t minus, because it's minus 6t, minus 3, all squared. Okay, so you can always even keep that 9 in this form, or just remember that that's the value that's going to go here for your binomial. This -9 inside my bracket, I have to multiply by -4 before I can remove it from the bracket. So -4 times -9, positive 36. And then, of course, still I'm left here with plus 6. Simplify -4 t minus 3 squared plus 42. Now and this is, of course, h. h equals -4 t minus 3 squared plus 42. What is the maximum height of the ball? If you're remembering vertex form, the vertex is the point HK. And here we have our h is 3 because we changed the sign when we bring it out, and 42. Therefore, the maximum height of the ball, and you can write this out as a full statement, is 42 meters. Okay? Part B here would probably only be worth maybe 1 mark because you've already done the work, the algebra you've already done. How long does it take the ball to reach this height? Well, remember, my h and k values are like my x, y values. This is my x, this is my y, so to speak. When am I at 42 meters? I'm at 42 meters when x equals 3, or in this case, of course, it is when t equals 3. Or, and double check, was this minutes? Don't do silly things like that. T is in seconds. And if you think about it for a minute, that's going to make sense, right? So at 3 seconds. All right? So hopefully that makes sense. For part A, this is where the algebra initially had to get done. This would probably be worth 3 to 4 marks for part A. Part B, 1 mark. For part C, how high is the balcony? So this you have to put into context, and I'm just going to rewrite my function, but I'm going to write it in vertex form. Okay, so I had -4 t minus 3 squared plus 42. So think about what this is asking. How high is the balcony? The ball is at the height of the balcony before it's thrown. So actually, let's get rid of that, sorry. When t equals 0 then, we have the height of the balcony. Because we can solve for h, and it's before the ball has been thrown, and that's how we know the time. As long as you make that connection, you're fine. So you'd be given 1 mark for knowing that. You would then be given probably a mark for your substitution. You're going to have 0. And then for your final execution of it. So here you have -4 times -3 squared will be 9, positive 9, plus 42. And you'll end up here, -4 times -9 is -36, plus 42. Simplify, you get 6, and then your final statement there. Therefore, the height of the balcony, I'm not going to rewrite this statement, but you could. The height of the balcony is 6 meters. Okay, and that would probably be 3 marks as well. Hope that's helpful.